In this video, I'm going to discuss about this Diels Alder reaction, which is pulled out from the degree first semester syllabus. That is chapter 5, acyclic hydrocarbons under the properties of alkanes. Let's know what is this Diels Alder reaction is. So this is an addition reaction. This is an addition reaction of the conjugated dienes, where the conjugated dienes here, this is a conjugated diene, right? What's a conjugated diene? A diene in which the double bonds are present in conjugation with each other, or the double bonds which are separated by one single bond are called as the dienes. So this is an addition reactions where a conjugated diene reacts with a simple olefin or the simple alkene with a double or a triple bond, that is alkene or alkyne it may be, to form a six-membered ring. This is called as an cycloaddition because this is resulting in the formation of a cyclic structure, which is a six-membered cyclic structure. So the Diels Alder reaction is nothing but the addition. It's a cycloaddition reaction where a diene, which is a conjugated diene, reacts with a dienophile. The dienophile is nothing but a compound with a double or a triple bond or a simple olefin here, or a substituted olefin also it can be, resulting in the formation of a six-membered ring, that is a cyclic structure which is formed here. So this is what is Diels Alder reaction. Here, this diene, this is called as a diene, there's a conjugated diene. This is giving 4 electrons, that is a pi electrons it's donating. And this dienophile, which is an alkene in this case, is giving 2 electrons for the reaction to take place, resulting in the formation of this six-membered ring here. In this case, it's a cyclohexane. So here, 1, 2, 3 pi bonds are broken here. 1, 2 and 3 pi bonds are broken, and 2 new sigma bonds are formed here. One here and one here, 2 new sigma bonds, and one more pi bond, which is a new pi bond which is formed here. So 3 bonds are broken and 3 bonds are being formed here. 3 pi bonds are broken in here. These are the broken bonds, and out of 3 new bonds which are formed, this is new 2 sigma bonds are formed, and 1 pi bond is being formed here. So if we observe carefully here, 3 pi bonds are broken and 2 new sigma bonds and 1 new pi bond is being formed here. So this is called as 4 plus 2 cycloaddition reaction, because the 4 pi electrons of conjugated diene and this 2 electrons of this dienophile are participating in the reaction, resulting in the formation of a cycloaddition product here that involves 4 pi electrons of the diene and 2 pi electrons of the dienophile here. So this is a cycloaddition reaction where a new cyclic structure is being formed here, and either this diene or dienophile can be substituted in this case. If suppose if we are taking this substituted dienophile, this results in the formation of a cyclic product which is again substituted. So again we get the substituted derivative of this cyclohexane when we take the substituted dienophile or the substituted diene. And this is the most powerful method for the synthesis of unsaturated six-member rings. This is unsaturated because of the presence of this double bond here. So it's a very powerful method for the synthesis of this six-membered ring, which is unsaturated here. And if we see the mechanism of this, it's a concerted mechanism. That means it is taking place in the single step. That means the formation of the new bonds and the breaking of the bonds is taking place in the single step here. So if you take this diene, it is a 4 pi electron system. Resulting in the formation of this transition state, which is a six-membered cyclic transition state, and resulting in the formation of a six-membered cyclohexane here, which is a cycloaddition product here. This is 4 pi plus 2 pi cycloaddition, or simply it is called as 4+2 cycloaddition mechanism. And here when we see this Diels Alder reaction, that the dienes here which are having the electron, the normal, which are the normal dienes which are taken or which are participating in this Diels Alder reaction is the dienes which are having the electron donating groups. This nothing but CH3 here. So the Diels Alder reaction is favored by the dienes having the electron donating groups. That means it's getting electron rich. We are making this diene electron rich. Electron donating means electron rich. And the dienophiles which are having the electron withdrawing groups here, see. The dienophiles, all the aldehydes, ketones, or the cyan or the nitro groups which are present on these dienophiles favor this Diels Alder reaction, which are electron withdrawing groups, means that we are making this electron deficient here. So Diels Alder reaction are favored with the dienes having the electron donating groups, and the dienophiles with the electron withdrawing groups are favorable for the reaction to take place. And this is a thermodynamically favorable reaction because the two new sigma bonds are being formed and pi bonds are converted into these stronger sigma bonds when compared to that of the pi bonds. The sigma bonds are thermodynamically favored bonds. And we look at this examples of this Diels Alder reaction. Yeah, this is what we are taking the substituted dienophile here, and this is the diene where the reaction will take place like this, resulting in the formation of the cycloaddition product. In this case also the same thing, the shifting of breaking and the formation of the new bonds where this substituents are present on the same face of the molecule. This is above the plane of the molecule. And in this case, the substituent are present above and below the plane of the molecule, that is on the opposite sides of the opposite faces of the molecule here. So let's look at a few more examples of this Diels Alder reaction. The mechanism is something like this, and the position of this substituent is not changed here. Same thing. And if you look at this, this is what is happening, and this is the addition product which is formed, and this is a six-membered ring. The six-membered ring is a common in all of them. It results in the formation of a six-membered ring here. So if we add alkene to this conjugated diene here, this is what is happening. So here is we observe this, the six-membered ring, and to the plane this is attached here. Okay. Now, yes, this is also the same thing. Well, again, a six-membered ring, if you observe here. Yes, resulting in the formation of this addition product here. Yes. This results in the formation of this product. And if you take this NO2, if the addition is taking place something like this, we are getting this product here. Yes. There's a methyl group here which needs to be present for the reaction to take place. Yes. This is what how the addition is taking place here. And this one also, if you observe this carefully, this is what is happening, and bond formation is between these two here, resulting in the formation of this new product. Yes, 1, 2, and 3. This one is nothing but this is above the plane of the molecule. That's it. So the new sigma bond formation is shown by these dotted lines here, just for a reference. So these dotted lines refer to this new bond formation here. So this one here is the new bond formation, and this one is above the plane of the molecule. Done. This is what is Diels Alder reaction.